Hello, everyone. Welcome to the first workshop for UPE Make this semester. As you may know already, this is an Arduino workshop. You won't really need to download anything. You just need to create an account on Tinkercad. It's actually easier than it sounds. You can just literally just go there and log in through your Google account. So that's really easy. I'm gonna start reading questions. And if you guys have any questions, don't be afraid to ask. I'm here and Charles is here, so we can answer everything.
Yeah.
Yes, it's Miguel. That's me. Hi, I'm Miguel. I'm currently a committee member for UP, and if you guys are interested in, helping out and maybe creating workshops for us too, you can also become a member. We have the applications open. So yeah, this workshop is done by UPE, of course, part of UPE Make. We have a couple of upcoming workshops. One of them is 3D modeling and 3D pens. That's going to happen on October 1st. And then we have the Raspberry Pi workshop. That's going to happen on October 5th. Both are really cool. And if you're interested in those topics, for sure, come by and check them out. If you're interested in becoming a member, go to that link. There it has all the information and the Discord and everything. So yeah, the Discord. Someone was asking for it, so there it is. Our social media. Well, a little longer if you guys actually want to add it. And yeah, this is our Arduino workshop and we're going to be using Tinkercad. But before getting into that, yeah, the social media. Before getting into that, I want to start introducing yourself the idea of the Arduino. And what is an Arduino? You can see commonly, like on the internet, is commonly referred to as a microcontroller, but in reality, it's a little bit more than that. It's like a PCB that holds a microcontroller, but also holds quite a bit of other functions. For example, it has already a voltage regulator in it, so you can actually power it with an external battery. It has built-in LEDs, so you can start prototyping without even having to really buy LEDs. It has, for example, it has a serial USB to serial, another microcontroller inside it, and USB to serial, so you can actually just plug it to your computer and program it straight away through USB. Usually, if you're programming microcontrollers, it's way harder because you need a device that is designed to program microcontrollers. The Arduino just skips all of that, and it's really easy and useful to develop. But now I want to get into what exactly is the microcontroller part of the Arduino. And a microcontroller is a small processor, a small chip that is going to be able to read the inputs that you give it through the pins. And you can program it in such a way that you can perform the tasks that you want out of the information that you were given. So for example, if we have a button and I press it, I want to program my microcontroller to turn on an LED. If I have a distance sensor and it sees that we're getting too close to a wall, the microcontroller is going to be able to detect that, and we're going to program it to, for example, move the other way. Those are just a couple of examples of things that microcontrollers are really useful for. And as you can already imagine, they can be great for projects that, for example, robotics projects that don't really require a lot of processing power, but they require sensors and pins and stuff. I'm going to be reading questions, so if I stop, it's because of that. Yeah, I think Charles is going to be taking attendance, and I wouldn't worry. If you just came in, welcome and happy to have you here. So yeah, that's a pretty brief introduction of what an Arduino is. It basically is a microcontroller, and we can use it to detect inputs and program the outputs to perform the tasks that we want. So why would you use an Arduino? I mean, after all, there are many other microcontrollers in the market. Well, first of all, the Arduino is open source. And that's always good because they provide you not only with the schematics, but also the PCB design, the firmware, the software that makes the Arduino run. And this allows people that are interested to be able to see how the Arduino works. This allows other people to, for example, create their own Arduino boards. Or even today we're going to be using an online tool called Tinkercad, and they have an Arduino simulator. This is possible thanks to Arduino being open source. They were able to grab all the code that makes Arduino work, and they implemented it into a web design, a web simulator. Those are a few of the advantages of it being open source. There's actually a couple more, and I'm going to mention them later on. It has a large community, and whenever you're starting with a new project and you want to learn, I think the way to go is just to go to the platform that has the biggest community, because it's going to have the greater amount of tutorials. It's going to have the greater amount of support. And at the end of the day, that's going to make the difference between you just getting frustrated and not really feeling progress, and you just getting your projects done. It has a bunch of libraries available, and this is directly correlated with the incredible amount of modules that the Arduino has. Basically, you have, for example, OLED screen modules. You have ultrasonic distance sensor modules that we're going to use one of those today. You have LED strips. You have many other things, and the community already writes libraries that makes it so much easier for us to use that without having to truly understand every little detail that makes it work. So we can just create rapid prototyping. It has a simple programming environment because, again, before the Arduino, if you wanted to program a microcontroller, you had to do it through C, and it was really involved. You had to not only take into account registers, binary data, a lot of stuff that just to make a simple project, it was a really steep learning curve. And Arduino basically got rid of all of that, and they just implemented a way simpler programming environment that is really similar kind of to Java or C#. We're gonna see it today, and it's really easy to just pick up and get into. It's inexpensive if you buy the clone boards, and this is related. This is really closely tied to being open source, since all the schematics and everything is available. Companies were able to create their own Arduino boards, and they sell it for cheaper. You can basically get an Arduino shipped to your house for less than $10. So that's a good way to start. It's multi-platform, so you can use it in your Windows computer, your Mac computer, or your Linux. And finally, it's USB programmable. So as I already told you guys, you can just plug it to your computer and it's gonna work. You don't really need to worry about buying a programmer or anything. It's just gonna work. So yeah. If this is your first time seeing this, it may seem a little bit scary, but as we know, the Arduino, the most use we get from it is by using the GPIOs, and the Arduino has basically a set of digital pins, analog pins, power pins, and serial communication pins. For now though, for this workshop, we're only gonna focus on the digital and the analog pins, and some of the power ones to power a couple of the modules that we're gonna use. But basically all you need to know is digital signals are zeros and ones, right? Low or high binary. To perform those kind of activities with the sensors that we're gonna use, we use the digital pins. The analog ones are really useful to read analog signals. For example, if we use a potentiometer, those give out an analog signal. We're gonna be able to read the exact value with the Arduino using the analog pins. And finally, we have the power pins. If we have a module that uses 5 volts, you can just connect it straight to here. You don't need to worry about having an external power supply or anything. I hope that was not too confusing. We also need to realize, and this is, I'm gonna go a little bit deeper in it, but the Arduino also supports PWM, which is a protocol that we use to kind of mimic analog signals, but using digital pins. And for now, all we need to know is that only a few of the pins in the Arduino are able to do PWM. In this case, it's the pin number 3, 5, 6, 9, 10, 11. Basically all the pins that have a tilde in it. If you guys have any questions, please go ahead and ask. Will we posting the slides on Discord? I think so. I don't see why not. I'm gonna post them after the workshop is done, if you're interested, for sure. But yeah, what are we gonna be learning today? And I wanna take an approach, more a hands-on approach, instead of teaching you guys the essentials and then going there. I just wanna start like with projects, and then we're gonna learn the essentials along the way. And my hair is crazy today. I'm sorry for that. But yeah, we're gonna start by creating a simple blinking LED. Then we're gonna use PWM signals to transform that blinking LED into being a fade in and fade out LED. Then we're gonna introduce a potentiometer, and we're gonna read the value that it has as we start rotating it. Then we're gonna introduce a servo motor, and we're gonna actually move the servo motor when we move the potentiometer. So we're gonna be connecting two pins together, two modules together and making them work in real time. And finally, we're gonna use a distance sensor, which is really common in robotics projects. So if you're ever interested in creating a robotics project or interested in our next workshop that is actually gonna be building a robot, just stick in with us because it's really cool and you're gonna see the basics of how it works. So yeah, let's just start our first sketch. And Arduino calls their own programs sketches, so I'm just gonna call them sketches too for this workshop. But yeah, it's a blinking LED sketch. And as you can see here on the right, I don't know if you guys can see it, but yeah, we have our LED. And one thing to note is that LEDs are polarized items, kind of. They have a negative pole and a positive pole. So we need to connect the negative, which is the cathode in this case, to the ground pin, and the positive to the, well, I chose to be pin 13, but you could choose any other digital pin. And finally, we're gonna use a resistor in between the connection, because if we don't use a resistor, a lot of current is gonna pass through the LED and it's just gonna burn down. Not literally, but it's just gonna stop working. So we use a resistor to prevent that from happening. So yeah, the terms that I'm gonna introduce is using digital signals with Arduino, the setup function, the loop function, digital write that we use to, set a pin to be either 1 or 0, high or low, as we were talking about before. And finally, the delay that we use to time things that happen. For example, if I want to turn it on, then I want to wait for a couple of seconds. That the delay function is useful for that. So I think we can just go straight ahead and get into Tinkercad, right? So yeah, let's go. Tinkercad.com. If this is your first time here, you basically have the option to join now or sign in. For now, I'm just gonna sign in, and you guys can see that you can actually use sign in with Google. So you don't really have to really create an account or anything. So just, if you have your Google account connected, you can just do that. Once you're here, you're gonna be presented with 3D designs, and Tinkercad is commonly known for being a really cool online 3D modeling software, which is really easy to get into, but we're actually gonna use the circuits simulation part. So get inside, get into circuits, and then you're gonna create a new circuit right here. I'm gonna wait a couple seconds for you guys to all be in the same page. We're not gonna be using a class code. Actually, just sign in as if it was a personal project. You're not really gonna need a class code. So yeah. If you guys have any questions, let me know, but I'm gonna wait a couple seconds. Okay, so I go here, I create a new circuit. Well, if we go here, we're presented with a little playground, right? We have our place where we're gonna select and place all our electronics elements. Then we have like a toolbox of sorts where we can search the items that we're gonna put into the playground. Then we have a start simulation button and a code button. So let's get started and just search for an Arduino here. I'm gonna use the search bar throughout the workshop. So yeah, I just type Arduino and I drag it into here. And as you can see, we didn't even need to buy an Arduino, and we already have one here to play with, which is amazing. I love Tinkercad, honestly. But yeah, we also are gonna use an LED, and we have it there, but yeah, you just search it. Finally, a resistor, which we also have here. So for the connection, you have the negative side of the LED, the cathode, and I'm gonna connect it to ground. And then the positive, I'm gonna connect it to pin 13. I like changing the colors of the cables so it's easier to read. But yeah, so far this is our first circuit. And it's a pretty simple one, but it's gonna be our gateway into understanding digital signals with the Arduino. So once you have your circuit set, and I'm gonna wait a couple seconds if any of you guys haven't got it. Once you have it, then you can start getting into code. So yeah, once you open code, you're gonna see here, they present you a programming interface that looks kind of like Scratch. And even though it's great to start learning, you can also go here and select text instead, and then continue. This is more like what you're gonna find in the Arduino IDE. Actually, it's the same. So they already gave us with an example. They already gave us an example code. I'm just gonna go ahead and get rid of everything that's inside the void. Everything that's inside the setup and the loop function. So we can have our clean, a clean sketch to start with and program. So if you guys are all up to here, fine. You can see that we have a setup and a loop. And if you've ever programmed with Java or other object-oriented programming languages, or I mean, any kind of language really, you know that setup is really useful for like starting. Once you start the program, the tasks that you put here are gonna happen once, and the loop is gonna happen indefinite amount of times after the setup. This is kind of like C. It's kind of like C, but not really. It's Arduino's own programming language. It's really inspired in C, of course. It's trying to get as close as the language of the microcontroller as it can. But once you start getting more in depth, you're gonna see that Arduino gives you a lot of stuff that makes it really easier to get, to start prototyping. But yeah, you can see it as C, honestly, most of the time. So yeah, this is a really simple sketch. And as I told you guys in the beginning, these pins are called GPIO, and that stands for General Input and Output. And the thing is, you can set these pins to be either input or output. So you actually need to tell the Arduino in the beginning, what mode do you want to use the pin in? So I actually want to use my pin 13 as an output. So the pin mode function is going to allow you to determine the mode that you want to use for your pin. Now, what I want to do is for this pin to be on and then off, basically to be high and then low. So when you want to write digital signals with your pins, with your digital pins, you use the function digital write. Then you set the pin number, and then you set the state, which in our case is high. Then since I want it to go low after, so it blinks, right? I will do the same, but with low in this case. However, if I start this right now, I told you guys already that the loop function happens indefinite amount of times. Since there's no delay in between these two functions, this is gonna happen so fast that you're not gonna be able to see the LED blinking. So to counteract that, we use Arduino's delay function. So we're gonna add two delay functions, and actually the delay function works in milliseconds. So if I set it to be 1000, it's actually gonna be the same as if I set it to be 1 second. So even though it looks like a lot, it's really not, it's just 1 second. My wires, yes, they are, that's because you can actually color code them to whatever color you want. If you select the wire, you can make it be green, blue, or whatever. For this workshop, I'm gonna try to stay consistent with the coloring, so it's easier for you guys to see, but you can make them whatever color you want, honestly. That's where your creativity can go into play. But yeah, if we see right now, we have a LED. In the setup, we are defining the pin to be an output pin. And then in the loop, we're making it be high, then we wait for 1 second, and then low, and we wait for 1 second. If we start the simulation, you're gonna be able to see it blink as we want it to. So yeah, this is our first Arduino code, and it's a really simple one, but it's a really great way to see how to use digital pins and writing digital signals. I hope you guys understood, and if you have any questions, just ask away. I have a question for the setup function. Will we have to set the ground pin to be? Okay, the ground pin, since its only function is to be ground, you don't really need to set it to be anything, because the ground pin is never gonna be an output or an input. It's just gonna be ground. So don't worry about defining it. You just need to define the digital pins from 0 to 13. We don't have to wire it to power. Well, Gustavo, the cool thing about the pins is, you know, we set them to either be zeros or ones. You know, it's digital logic. But what's really happening is the pin is being set to be either 0 volts or 5 volts. Since our Arduino works with 5-volt logic, when you set the pin to be 1 or high, it's actually just setting the pin to be 5 volts. So this is becoming a 5-volt supply of power, pretty much. And then when you set it to low, it's becoming a 0-volt supply of power. And that's why the LED goes from being on to off. I hope that's a good explanation. Oh, yours said exclamation point. Did you use a resistor? Because if you don't use the resistor and you connect it, what's gonna happen is your LED is gonna give you an alarm. And this is what I was trying to tell you guys. And basically, if you connect an LED straight to the power, since the LED is gonna take as much current as it can, it's basically just gonna burn. And this is just giving you an alarm saying that the LED is basically taking more current than it should. And if you actually did this in real life, your LED will be broken. So you will need to get a new LED for that project if you didn't use the resistor. Oh, you used the resistor. Well, in that case, I don't really, I mean, you're saying here, if you use the resistor, try this. put the resistor, connect it together, and then click the resistor and make sure you have at least 300 ohms in the resistor. In this case, I set it to be 300, and this symbol is ohms, and that's gonna be able to make, to let me run the sketch without any problems. Oh, you got it. Well, cool. So yeah, for now, we're done with the fade sketch. So let's keep going, right? Sorry, with the blinking LED sketch. So this is the source code, but we already wrote it. This is for you guys later. If you see the presentation by itself, you have the source code to work with. Now, I'm not happy with just having an LED blink. I wanna have the LED be able to fade, basically make a smooth transition between off and on. If you guys think about it, since we have digital pins, and by definition, digital pins can either be 0 or 1, we really shouldn't be able to just have a fading effect, because the LED will only be able to go from 0 to 1. Well, this is where PWM signals come into play, and it's a really cool kind of protocol that allows us to use our digital pins to behave like if they were analog pins. And analog signals, as opposed to digital ones, they are able to go through a whole range, not only from 0 to 1, they have a lot of granularity in between. So I'm gonna actually present you guys better what PWM signals are, and I hope you guys can write your mind about it, because the first time I learned about PWM, it was kind of confusing. But yeah, the terms that we're gonna introduce is PWM for Arduino, the function analog write, which is how we write PWM signals with our pins, and finally the for function, for loop, sorry. This is more just basic programming, but if you guys have never programmed before or anything, yeah, you're gonna see how we use a for loop. So yeah, PWM signals, as it says here, and I'm gonna use the pointer. It's a technique that allows us to create analog signals out of digital pins. Our Arduino can output PWM signals that range from 0 to 255. And as I already told you, that's basically from 0 to 5 volts and any value in between. So if we see at the left, we have 5 different diagrams, and they are all different, representing different PWM signals. The first one is a PWM signal of value 0, or duty cycle 0%. And this is the same as a digital signal that is just low or 0. And if you see it, the signal never goes up or down, and it's just all the time it's flat. So this could be the same as a digital signal of 0. However, if we go next, we see this signal and it's being set to high for only 25% of the time, and then low for the rest. And then again, we see in the other one, it's being set high for 50% of the time and then low for the rest. And then the other one, 75. What's happening to the voltage if we just decide to set the signal to be high for a percentage of the time instead of being high all the time? Well, if I create a PWM signal of 50% duty cycle, my pin is gonna output a signal of 2.5 volts instead of being a signal of 5. So this is going to allow me to be able to output different voltages from our pins that are not just 0 or 5. So this can be really useful for not only for the project that we're going to do right now of making an LED fade, but you can imagine many other things. For example, setting a module to rotate to to an exact number just with one pin, well, you could use a PWM signal. And we're gonna actually use that with the servo motor. Yeah, this is kind of hard to explain, but I hope it makes more sense once we start getting into the sketch. And as you can see here in the right, you basically set PWM signals from values going from 0 to 255. So yeah, 0 will be a PWM signal that looks like this. 255 will be one that looks like this. And then all the values in between, you can see it. So I say I stop talking about this and we just go straight into the sketch, right? So yeah. Here we have our previous sketch. And I told you guys that if we wanted to use PWM signals, we need to use a different pen. We need to use the pens that have a tilde next to them. So for this project, I'm just gonna go ahead and I press Shift and I select, or I just select the cable, for example, and I delete them one by one. Then I'm able to go ahead and, oh my God, sorry. I actually need the resistor. So I'm gonna go ahead and use, for example, pin 11. And I change the colors just to stay consistent. So yeah, now we have our LED connected to a PWM pin. So let's start coding it, right? I'm gonna go ahead and get rid of this because our code is gonna be quite different. And we're gonna have to edit this since we are using pin 11 now. So yeah, we're setting the pin 11 to be output. Now, if I wanna set this LED to be a value with a PWM, you will just use the function called analog write. We set the pin number and then the value. No, never mind. Wait, yeah, that's right. The analog write, the pin number, and then the value, which is, in this case, I want it to be 155. So if I do this right now, you're gonna see the LED is gonna, oh, we have an error. Yeah, I forgot a curly bracket right there. If we see it right now, and I'm actually gonna go ahead and lower the resistance so it's easier to see, I'm gonna put it into 300 ohms. So if I set the LED to be 155, it's being lit at half the brightness. If I set it to be 255, it's gonna be brighter than before. And if I set it to be a low value like 30, it's gonna be really faded away. So how can I create a function that allows me to smoothly transition between fading and really bright? Well, we can use for loops for this. And the way a for loop works is you have a condition. Sorry, you have a counter variable. In this case, it's gonna be I. Well, actually, let me call it brightness. Then you have a condition. Brightness has to be less than 255, which is, sorry, less or equal than 255, which is the limit that we have in Arduino for PWM signals. And then finally, you have to have an addition, or it's like an operation, right? So at the end of every for loop, I want my brightness to be added by 5 numbers. Now, if you do this, you're gonna notice that you can actually just go ahead and, well, I mean, what's gonna happen with this for loop? We're starting with a brightness, and then we are at every time the loop happens, the brightness value is gonna go up. Sorry, this has to be initialized to 0. So every time the loop function, the for loop happens, the brightness value is gonna be added by 5. And once it reaches this number, which is 255, the for loop is gonna stop. Yeah, the brightness turns up by 5. Because if I did it, I already tested it with 1 and it's just too slow. So you could just do brightness plus plus and it will work, but it will work slower. And if you do it like 10, it's gonna happen twice as fast. So yeah, for now I'm gonna use 5, but you can actually try whatever value you want and you can see how it behaves. So this for loop right here is gonna make it go from 0 to 255. Then we're gonna have to create a for loop that makes it go from 255 to 0, but let's worry about that later. So what I'm gonna do now is analog write. I set the pin, which is 11, and then I'm gonna set it to be the value of brightness. This is outputting a PWM signal from pin 11 of value brightness. Then I'm gonna have a quick delay of 30 milliseconds. I always like adding delays because it actually performs better if you give it delays. If you don't give it delays, it's just gonna do the loop so many times that the simulation just starts kind of choking. But yeah, so we have our first for loop, and this is, if you start it right now, it's gonna go from 0, or it's just gonna have an error, of course. What is happening now? Okay. For loops needs curly brackets. It's like I don't even know how to program. Curly bracket, yeah, my bad. If you see it, it goes from 0 and it's going like up. It's hard to see in the simulation, but if you have a real LED, it's way more noticeable. It just goes from pitch black to full brightness. Now let's create another for loop. Yeah, right? You see it. I mean, it's kind of happening. Then I'm going to create another for loop. I'm going to use the same variable, but this time I'm starting at 255. Then brightness has to be greater or equal to 0, and brightness 5. So here is, we're gonna basically do the same as before. Analog write 11 and brightness, and then another delay of 30. And hopefully it doesn't have an error right now. We made it. Okay, so if you see it now, it's fading. So it's a really cool effect, and it's able to be done thanks to PWM signals. We're actually gonna play with PWM signals more in this workshop. Just wait and see for the other examples. If you guys have any questions right now, ask me. I'm gonna wait a couple seconds so you can look at the code and make it work, and maybe play with the brightness value. For example, if I set it to be 50, if I set it to be 1, it's gonna be really slow. So I'm gonna actually set it to be 1. So yeah, it's 5 times slower.
Is the second part of the for loop to get it to fade out? And the first part?
Exactly.
Okay.
Because you're starting at 255. Oh, actually, this will be minus minus. Yeah. You're starting at 255, and then you're subtracting values to this number until it reaches this condition. And every time the brightness happens, we're setting it in the PWM signal. But yeah, if we don't have any more questions, I'm gonna keep going with the workshop. So yeah, we talked about PWM signals, and this is the source code. Actually, there's an error here. This is not pin 13, this should be pin 11. So be mindful of that if you're watching, if you're looking at this presentation later. I'm gonna fix that, but yeah. Now we're gonna use the analog pins and the analog read function to turn a potentiometer and be able to, you know, see the value that the potentiometer has. For this, we're gonna use, you know, analog read, and we're also gonna use the serial print functions that the Arduino provides us. So yeah, there's not, oh, of course. I wanna explain to you guys more or less how the Arduino actually reads the signals, the analog signals. As I told you guys, analog signals differ from digital ones in the fact that they are not ones and zeros. They are basically many values in between a range. So the way that the Arduino actually reads this, it has a built-in 10-bit analog to digital converter, and it transforms those values into digital numbers. And then it can be used in the Arduino in the logic with no problems. Those numbers have a resolution from 0 to 10,023. This is because of the 10-bit analog to digital converter. Previously, we used a range from 0 to 255 for the PWM signals, and that's because the PWM clock is actually 8 bits. If you look on the internet, you can see that if you have 8 bits, the maximum amount of combinations you can have is 256. But if you have 10 bits, the maximum amount of combination is 1023. So that's the reason why we're gonna be using this range when reading analog signals. To actually read them, you use the analog read function. And finally, we're gonna use a potentiometer to read analog signals. There's a question, so I'm gonna try. Yeah, right. Yeah, if you take any of the signals of system classes or logic design, this is something that you already saw, but I wanna give it my best explanation for the people that are new to these concepts. So yeah, let's go ahead into Tinkercad and start playing with a potentiometer. If I'm able to, oh, I hate Zoom. I cannot change between tabs right now. Well, oh, there you go. There it is. So I'm just gonna go ahead and get rid of my LED. In the code, I'm gonna go ahead and delete whatever is inside my loop function. And the setup. So we have a clean start. I close the code and then I'm back in the toolbox. I can search for a potentiometer or I can find it straight away. There's questions, so I'm gonna try answer. Note me as present. Yeah, Charles is taking care of that, but thanks for for telling us. If you press the R button as you're selecting something, it can rotate. So I'm actually gonna do that for this, so it's easier to connect. And the way a potentiometer works in simple terms is you have one of the pins connected to ground, and you see it here. One of the pins is connected to power, the other one is connected to ground, and the middle pin is gonna give a analog signal that ranges from 0 to 5 volts. In this case, since we're connecting it to a 5-volt supply. So it's easier, I'm gonna color code the cables. And yeah, this is all the connection that we're gonna need for this sketch. We're using analog 2, but you can use any of the analog pins. It really doesn't matter. You just need to make sure to use the correct one in your code, and that's it. You guys remember how for the digital pins, I had to actually tell the Arduino IDE if I wanted to use it as an input or as an output? Well, this is a cool quirk of Arduino software, I guess, since the analog pins are only useful to read analog signals. They cannot really give out analog signals. You can actually go ahead and skip the step of defining it. Since they are always going to be used for reading analog signals, you don't really have to define the mode. You can do it and it won't change anything, but you don't need to, and we're not going to do it. So for this, instead, what I'm going to define is the serial functionality. And in Arduino, if you want to be able to print values into the serial monitor, which is usually really useful when you're debugging a Arduino project, you know, you wanna be able to see the sensor readings that you have or the module readings. It's really useful to use the serial monitor. The Arduino basically gives information back to your computer and prints it into the serial monitor. It looks like a programming console that you would use in Java or stuff like that. You know, you're just printing values into a console. So you need to actually define it with serial begin, and then you put a baud rate. For now, don't really worry about that number. Just know that if you select a rate here, you have to select it in the serial monitor. Tinkercad doesn't allow you to select, but if you had the Arduino IDE, you will have that function. For now, just leave it as 9600, and that's all you need to know. So yeah, I'm gonna create a variable called sensor value. I'm gonna initialize it as 0. Then I'm gonna have sensor value. Actually, no. Let's just, instead of initializing it at 0, let's just go straight into analog, read, and then I set the pin to be A2. What's happening here? Well, the analog read function is going to read whatever analog signal the potentiometer is giving out in that moment, and it's defining that value. It's giving that value to this sensor value variable. And after, we're going to be able to just use serial.print sensor value. And now we're basically printing this value into the console. I'm gonna also add a delay because the simulation works better with delays. For example, 50 milliseconds. And yeah, this is also a pretty simple code. And if you started, oh wait. If you see the zeros are stacked next to each other, that's because I use print instead of println. Println is gonna basically make the next line happen. Sorry, it's gonna make the next print statement happen in the next line. So if you see it now, it's easier to read that way. So as I told you guys, whenever you have an analog signal, Arduino can read the value from 0 to 123. And that's because of the 10-bit analog to digital converter. So you may be asking yourself, yeah, that's really cool, but what uses can I get from that? Well, right now we're gonna connect a servo motor to Arduino, and we're gonna actually be able to rotate our potentiometer and make the servo motor rotate in real time. So that's one of the uses, but I imagine you can think of stuff. I mean, after all the volume knobs that we use in our cars and stuff like that are potentiometers. So yeah, this is how you read the analog value. So let's go. Well, first, if you guys have any questions, just don't be afraid to ask. I'm more than glad to answer. But if there's none, I'm just gonna go ahead into the servo motor sketch. So yeah, I hope I'm not talking too fast. This is the source code. And you can see here, I actually defined it. I actually defined the pin, but it really doesn't matter. Just so you guys saw that I didn't define it and it still worked, and it's because of what I told you guys. So it's just personal choice. Now, let's connect a servo motor to our potentiometer. My goal for this is that we're able to move the servo with our potentiometer. And yeah, we're gonna actually use a library this time. The Arduino provides us with a servo library. And that's one of the cool things about Arduino. You don't really need to know how to control a servo to be able to use it. You just include the library and you're good to go. This library has a couple important functions that we're gonna use in a specific, the servo.attach method and the servo.write. Attach is used to define the pin that is using the servo, and write is to tell it which degree to go to. What is servo actually? Okay, let me see if I actually added that into the presentation. Okay, there it is. What is a servo? Well, if you see here, I'm sure most of you guys already know what DC motors are. Well, a servo is basically a DC motor connected into a gearbox and then with a potentiometer in the shaft. What does this allow the servo motor to do? Well, this is going to allow our servo motor to have a lot of torque because of all the gears that are basically incrementing the torque in real time. And then the potentiometer, since the shaft is going to move from one direction to the other, the potentiometer can actually have an analog value, and the servo motor can use that to know exactly where the position is of the shaft. That's going to be easier to understand once we start getting into the sketch. But all you have to know for most of the DC motor servo motors, for most of the servo motors that you find in RC cars and stuff or planes, they go from 0 to 180. The purpose of the potentiometer is to know the current location of the shaft. That's the only purpose. What's moving the gearbox is the DC motor. Why would you want to know the location of the shaft? Well, servo motors are really popular into the RC planes community, and they use it, for example, in the flaps that you use to, to be able to make the plane lift or go down. In this case, you want the servo motor to move to a certain angle always, right? So if you move to an angle that is downwards, and I'm looking there even though the camera's here, this is my first time, I'm sorry guys. If you make the servo motor move to an angle that is downwards, then the plane is gonna be able to lift up, and then if you make it move the other way, the plane is gonna be able to lift down. What the servo allows you to do with the potentiometer is have a lot of precision in the angle that you're moving in. And I think this is really going to be easier to see in the sketch. So let me just go ahead and get in there. Oh, you got it. Perfect. 1 second.
Yeah, Miguel, we can't hear you.
Sorry, guys. Someone called.
Okay.
I'm back. So let's go ahead and start working with the servo motor, right? So we're here, and let's just add it, servo. If you press R, it rotates. I want it to be this way. So yeah, you have your shaft here, and this is gonna rotate in one direction and then in the other direction. And that rotation has a maximum range of 0 to 180 degrees. So if you see here the pins, one of them is brown, red, and then orange. You can always assume that brown is gonna be ground. So I'm just gonna go ahead and connect it there. Well, let me do a better job at it. Then the red one, I'm gonna connect to 5 volts. And finally, the orange one, I'm gonna connect to pin number 3. It really doesn't matter whatever pin you choose, but I chose pin number 3. So yeah, this is how our circuit looks like. And let's actually go ahead and program it.
By the way, it's just a question I had. Is there a chance that one of the ports could be overloaded?
Okay. Okay, I want to ask first, what do you mean with overloaded in this case?
Well, for example, there's now 2 different wires going into the 5
Pin number
volt
5
port and the ground one as well.
Okay.
Is there a chance that there could be too many lines going in at one point?
That's a really good question. And that's something you always have to take into consideration when you're developing, for example, a robotics project or anything that uses high power devices like a servo motor. In this case, if you only use a servo motor, you're gonna be fine. If it's a small one, you're gonna have no problems. But as soon as you start getting into higher power servo motors or higher power devices like LED strips, if you run it from the Arduino pin, you're just gonna possibly end up burning the Arduino. Why is that? Because each pin has a maximum current, has a maximum possible current of, I think is 40 milliamps. So whenever you're gonna use any device, in this case, I'm using a servo motor, you should search online, what's the maximum possible current that this device can pull in one time? And if that's below the 40 milliamps of the Arduino, then you're fine. You're allowed to use it, you know? Now, in this case, I just went ahead and connected 2 cables into the same pin because I was lazy, but you could use a breadboard. And if you guys want, I can actually go ahead and use the breadboard. It's the same thing. You will use a breadboard, and basically that allows you to connect multiple cables into the same 5 volt line without any problems. Should I use the breadboard? Okay, let me go ahead and use the breadboard. Yeah. Okay. Yeah, yeah, my bad. It can be a little confusing if you don't use the breadboard. If you've never used a breadboard, this is also a good introduction for it. So yeah, just search for a breadboard here. I'm gonna go for a small one. A cool thing about breadboards is most of them in the corners have 2 lines that are specifically designed for you to connect a 5 volt or any power line and then a ground line. So for example, and if you see, when I hover over one of the holes, the whole row lights up. That's because whatever I connect here is the same as if I connected it here. Like if I connect something here, like the ground line here, I'm gonna be able to connect a ground pin in any of the other possible breadboard holes that you have. And this is gonna make more sense once I start connecting everything together. So let's go ahead and get started. I'm gonna connect 5 volts into the 5 volt pin, ground here. Of course, I'm gonna color them because it's easier to see. So now, if I wanted to power my servo motor, I just go ahead and connect this to the pin that it's power. And then if I wanted to put the ground, I just connect it to the other pin. This is essentially, I mean, you guys can see where the power is going and the ground. Now the signal pin, I'm gonna connect it to pin number 3. And now let me add my potentiometer that I accidentally deleted before. A cool thing about potentiometers is that most of them, let me rotate it, their pins align with the pins of a breadboard. So you can actually just connect it to a breadboard like that. And if you see, when you hover over the pins, sorry, the holes in the breadboard, basically this entire column is connected together. This entire column is connected together, and this one is also connected together. We already know from before that the left one is gonna be our ground. So I'm just gonna go ahead and connect ground to ground that way, power to 5 volts that way. And finally, we have our signal, our analog signal, and I'm gonna connect it to our analog pin number 2, as we had before. So the breadboard makes it a little bigger, but it's easier to see. I hope it makes more sense now. I'm gonna leave it because it's different. I'm gonna leave it like this for a couple seconds so you guys can implement it into your own Tinkercad. And if you have any questions, go ahead and ask. I cannot stop but looking at the potato battery. I think it's hilarious that they have a potato battery in there. But yeah, I'm just gonna give it a couple seconds.
What does the -3, what is it used for exactly?
Actually, that's not a minus, that's a tilde. What it's
Oh,
telling
right.
us,
I didn't see it before, sorry.
no, it's okay, but just so you know, the tilde is really useful because it tells you which pins can be used as a PWM pin. For
As a
example,
what? Oh, PWM?
yes. For example, if I connected my previous project that we did, right, with the LED to pin number 13, which doesn't have the tilde, it wouldn't work because that pin is not rated for PWM. So the fade effect would not work here. That's why
what does PWM stand for?
It stands for pulse width modulation, PWM. We kind of already went through it. It's basically a technique that allows us to create analog-like signals out of digital pins. So that's how you're able to create, that's how you're able to output voltages that are different from just 0 or 5 volts from your digital pins.
All right, that makes sense.
So yeah, then yeah, I hope that makes sense.
I have a quick question.
Yes, ask, please.
For the potentiometer, is the order always ground and then pin and then power?
Actually, yes. If you see here, well, honestly, I couldn't tell you. I always just do it this way.
Okay.
But I mean, that's something you could try, or if anyone here already knows that info, please chime in. But I know that it works this way. The left one being ground and the right one being voltage. I mean, we could flip it right now and see if it works. Let's do that. I put the left one as voltage and the right one as ground. So, and let me I mean, we already have it programmed. So what happens? Let's see. It works. So you were right. You can set it whatever way you want. The
Nice.
important thing is the middle one is always the analog output.
Okay, got it.
Cool. Thanks for asking. I just learned something new too. So yeah. Let's go ahead and implement our servo motor into our project. To connect a servo to a PWM. Okay, I'm gonna read the question out loud. Is there a reason as to why we connect the servo to a PWM instead of an analog pin? You have to ask yourself, what are you doing with the servo motor and the pin? In this case, for the potentiometer, we're using the analog pin because we're reading the analog signal from this potentiometer. But in the case of the servo motor, I'm not gonna use it to read any value. I'm actually gonna give it a value, right? And the value that I give it, I'm pretty sure is done with PWM. So since I'm outputting a value, that's why I'm using pin number 3. Pin number 82, it wouldn't really allow me to output a value. I hope that answers the question. Makes sense. And what I'm saying is not completely true, because you can actually, if you run out of digital pins, you can actually use the analog pins as digital. You just need to define them as output, and then you're gonna be able to use them as digital. But for any of the projects that we're gonna make, we're not gonna reach that necessity. But if you're really running out of pins and you really need digital pins, you can actually use some of the analog as digital pins for output and input also, I think. It's just kind of cool to know that. Yeah. So I hope it makes sense, and let's go ahead and get started. So for now, I'm just gonna basically ignore, I'm gonna comment it out, ignore the part that is reading the sensor value. I'm just gonna show you guys how the servo motors work, right? So first, we need to include the servo library. And in our case, the servo library is already in the files and everything in Tinkercad, so we don't have to actually get the servo library file and import it into Arduino IDE and then be able to use it. If you end up getting an Arduino kit and you end up needing to import a library from using the IDE, you can find a lot of tutorials that are going to help you. What I'm going to go through right now is like the process after you successfully got the library into the IDE, right? So once you have the library included, you just include servo.h. And this is going to allow us to use the servo library. For the servo library, you need to create a servo object. So servo, and I'm going to call it my servo. Then you need to actually define this servo object. Sorry, you need to initialize my servo dot attach and the pin that I'm using for it. And then finally, you're gonna be able to go ahead and my servo dot write, and you give it an angle. You start from 0, then you put a delay. I'm gonna put a delay of 1 second. servo dot right, and then I'm gonna move it to 180 degrees and another delay.
I'm sorry, how do you include the library for the servo?
Okay, so I cannot really show you guys how you include a library with Tinkercad. If you have the Arduino IDE, well, I will have to download it. I don't have it in this computer. That's why I'm basically saying if you need to include a library, if you end up actually getting an Arduino, there's a ton of tutorials. You just have to ask, you just have to type how to include a library. But once you're able to actually grab the library file, which is a zip file, and include it into the Arduino IDE, then you can just use this line right here. Include servo.h, and that's all you need to include it. Actually, Tinkercad has a few libraries. If you click here, these are all the libraries that Tinkercad allows us to have. It's not a lot, but it's some, you know, it's some of them, and you can use them with some of the modules that Tinkercad provides us with. I think my light is, yeah, I think I need to turn on the light. Well, it doesn't matter. I hope that answered your question. I mean, you just do this line right here.
No, it did.
Okay. We're basically right here, we're creating a servo object. Then we're defining the pin that is using it. You know, the pin that uses the servo, that controls the servo. Then we're able to give it an angle value. If I set it servo.right 0, this is gonna move to the 0 angle. And then if I set it to 180, it's gonna move to 180. So let's see what happens. You see, it goes from 0. It's not really going to 180 because I don't think I gave it enough time. Let's go and give it 2 seconds. There it is. We're going from 0 to 180. I hope that makes sense. That's more or less the functionality that you can get out of a servo motor. But now, I'm gonna ask myself, what if I don't want it to move by itself? What if I want it to move with my potentiometer, right? That will be cooler in my opinion. Well, let's go ahead and actually try that, right? I'm just gonna get rid of this. And we have to start thinking about what we have here. I have a variable that is called sensor value, and it gives me a value that goes from 0 to 123. Sorry, to 1023. I know that my servo motor takes a value that goes from 0 to 180. So if I just go straight away and I do my servo dot write sensor value. If I go and I do this, is it really gonna behave like we want? Not really, because our sensor value is going way above 180. You know what I mean? I hope that makes sense. So we have a problem here, right? I actually want my value. That's a solution, and that would actually work, Ronaldo. But another solution that is, you have to think less about it, I guess. Arduino has this function called the map, Arduino map function. What the map function allows you to do is you give it a variable, then you give the range that the variable was originally in, and then you give it a new range. So let me go ahead and try that, right? I'm gonna map. I don't know if it's in lowercase or uppercase. Let me check it again. It's uppercase. Sorry, lowercase. I give it my sensor value. My original range was from 0 to 1023, and my new range is from 0 to 180. I don't really care right now of printing the serial variable, so I'm just gonna get rid of that. And I'm gonna run it. So what's gonna happen now is when I move my potentiometer, the servo motor moves accordingly. But I don't know if you guys notice, it's kind of moving backwards. So a quick fix could be just to change the range. I'm gonna put it to be from 180 to 0. And if I run the code now, it's like moving with us. I find this project, I mean, this is pretty simple, but it's kind of cool. And you get to really understand analog signals and how to convert them into the value that you want. So I hope you guys liked it. And if you have any questions, yeah, see you guys. If you have any questions, just ask me. We're really close to ending the workshop and it's kind of long, but I just wanted to teach so many things. If you guys have to go, no worries. I'm gonna keep going because we're kind of late. So,
how do we
yeah.
save the how do we save the project in Tinkerpad?
Well, let me change the name first. Yeah, they like creating random names.
Well, since I work with Tinkercad a lot, it saves your work automatically.
Yeah. Since I'm basically deleting what I'm doing and putting new things in, it's not really saving it because I'm deleting the stuff. You will need to create a new Tinkercad project for every sketch that you create, basically. My servo isn't turning. Did you connect it? Did you connect it exactly like we have it right here? Make sure of that. Because if you miss up tiny little thing, yeah, it just doesn't work. I'm gonna give you a couple more seconds, sorry, a couple minutes to look at it and see if you can figure it out. And then we're gonna use one of these modules that is ultrasonic distance sensor. I don't know if you guys have seen this. These are pretty popular in Arduino robotics starting kits. And basically it uses ultrasonic waves to detect objects and the distance that they are in between. And I'm pretty excited to show you guys the ins and outs of how it works and all of that. I really hope you get to your servo motor to work. I'm so sorry if it doesn't work. You can always check the slides later on and check all the connections. Since this is a simulation, if you did it exactly like I did it, it should technically work. It turns now. Perfect. That's what I like to hear. So yeah, let's go to the end. This is the most complicated sketch that we're gonna create, but it's also pretty cool and you get to understand how some of these modules work and yeah. So this is the ultrasonic distance sensor sketch. It checks that my idea for this sketch is to check the distance of an object and then print it in the serial console. The terms that I'm gonna introduce is a new kind of delay, which works with microseconds, and then the pulse-in function that is gonna allow us to read a signal and see how much time it took that signal to change states. I'm really bad at explaining it right now, but I hope with the visualization diagrams that I created, it's easier to understand. And how do these modules work? And this is pretty popular and really cheap. And that's a good thing. If you're trying to create a robot, it's pretty common to use more than one of these, and you can pretty much put one of them in every corner of your robot since they are really cheap, and then you can have it completely be aware of its surroundings in such a way that it's not really going to crash with any wall. That's mostly the main thing that our robot in the second workshop is going to be doing. So yeah, I'm talking too much already. So basically the way that this works is you have 4 pins. A VCC pin, which is the voltage, a ground pin, a trigger pin, and an echo pin. The trigger pin is gonna send a 10 microsecond, sorry, we need to send the trigger pin a 10 microsecond pulse. Then our ultrasonic sensor is gonna transmit 8 ultrasonic waves. Once the ultrasonic waves bounce in an object and come back, the echo pin is gonna output a signal, is gonna output a pulse whose length is the same as the time it took for ultrasonic waves to go out and come back. So if you see this visualization, we have our ultrasonic distance sensor and I have a wall here. Imagine I think it's 300 centimeters. After that is really not accurate. So yeah, I would use it for any project that you need that is really gonna be shorter distance than 300 centimeters. So if you see here, in my trigger pin, I sent a 10 microsecond pulse. This pulse triggered the sensor to send 8 ultrasonic pulses, right? So we're transmitting the 8 ultrasonic pulses after we send the pulse in the trigger pin. Once the ultrasonic pulses bounce in the wall and it comes back, our echo pin is gonna give us a pulse whose length is the time that it took for that whole process to happen. Now, how will we calculate the distance? Well, the cool thing about this whole sensor is that it works with ultrasonic waves, and ultrasonic waves move at the speed of sound. See you, Mariana. Since they work at the speed of sound, and we know the formula of the speed of sound, which is 343 meters per second, we can actually derive an equation to check the distance that the object was in based on the time that it took for the wave to come back. And that's the whole logic that we use for this. Basically, I converted the speed of sound constant to be in centimeters per microsecond, which is going to make it easier for calculations. And then you divide it by 2, since the whole process is happening 2 times. It's going to the wall and then coming back. So I just want to know one of the distances, not the 2 distances. So basically, we use this equation. Let's go ahead and program it in Tinkercad. In this case, since it's so much, I'm just gonna press Shift and you can select everything and I'm gonna delete it. You can also delete stuff one by one, and yeah. So I'm gonna add another Arduino here. And I'm gonna add my ultrasonic oh God. Go back, okay, there you go. I'm gonna get my ultrasonic, oh my God, I'm doing it again. I cannot. Let me try, I don't know what's happening. Oh, okay, there he is. If you come here, you actually see that we have the option to use 2 different distance sensors. And in reality, they are the same. One of them has 4 pins and one of them has 3 pins. Since I explained you guys how to use the 4-pin version, let's use that one right now. But just know that the 3-pin version, all that it's doing is connecting these 2 pins together and using it as one. So before sending the signal, in this case, you need to define the pin to be an output for the trigger. And when you're receiving the signal, you need to set it to be an input. That's the only difference between this sensor and this one. But we're gonna use this one. And this one is the most common one that you see in Amazon and stuff like that. So yeah. So let's connect it, right? I mean, by this point, we already know that VCC is gonna go to 5 volts. Some modules actually work with 3.3 volts. So before using some modules that you buy or anything, just research, because you don't want to burn your new module that you bought. You know, that's just sad. Then the ground pin goes to ground. Your trigger signal goes to one of the pins. It doesn't really matter. And your echo signal will go to any other digital pin. I'm selecting pin number 1 and 2. It looks really confusing now, but once I put the colors, I hope it looks better. Oh God, wait. Orange and purple. So yeah, we're connecting our voltage pin, our ground pin, the trigger pin that we're gonna give it a 10 microsecond pulse in the beginning, and the echo pin, which we're gonna use to read the time that it took for the object to come back. Sorry, for the ultrasonic waves to come back. So let's actually go ahead and start programming it. I'm gonna open the code tab. Wait, give me a second. I'm so sorry for that, guys. I'm gonna change to text again. And I'm gonna get rid of the default code that they give us, so we can start writing our own. So we have 2 pins. The trigger one, this one is gonna be an output because I'm gonna be giving it a pulse, a signal. So I'm gonna call it pin mode 2, which is the trigger pin. Okay, I'm gonna, ideally, you don't wanna call your pins straight away like that. You will wanna do something like this. Define trigger pin to be 2, and then define echo pin to be 1. This is one of those things that is like better practice, and this is going to allow us to basically do this output instead of having to type the pin number. So if next time I decide to change my cable to be, instead of in pin 2, to be in pin number 7, I just need to change that number one time up here, and the rest of my code is gonna work fine. Basically, exactly. It's like in Java, if you create a constant int of trig pin called 2. It's the same thing. The only reason why people use define in Arduino is because you have pins that are not only integer numbers. For example, you have the analog pins. So if I want to define the analog pin, I would just do A2, right? If I try to do that with a constant integer, I couldn't, because this is not an integer, this is a string. And it just becomes more complex, and just using the define is easier. I hope it makes sense, but it's pretty much just defining the pin to have a number. Sorry, to have a name. Then the other pin mode, echo pin, I want it to be an input, because I'm gonna be reading that pulse that it gives me to calculate the distance. Now let's go into the loop. And the loop is actually the same that I already showed you guys, and I'm gonna show it again to refresh. We're gonna send a 10 microsecond pulse. We're gonna wait for it to come back, and then we're gonna read the distance, sorry, the time of this second pulse that comes back in the echo pin. So yeah, as we already know, I can do digital write. At first, I'm gonna set my pin to be low, just in the case that the pin is high before, just to make sure that I'm starting it at a low spot. So my pin is set to low by default. Then, since all this is happening in microseconds, we actually need to use, if we use the normal delay function, we wouldn't get the functionality that we want. We want microseconds. So actually, Arduino created a function called delay microseconds that you can use for stuff like this, where you need more precise timings. So I'm just setting it to low for in the beginning for 2 microseconds. It doesn't matter. I could set this to be whatever value. The second one is important though. Digital write trig pin to high. And this one has to be 10. And then I'm gonna set it to low again. Digital write trigger pin low. So basically what we did here is, in coding terms, we simulated this pulse. And let me read the questions. Okay. Yeah, see you, Manuel. What do we do now? Well, we need to wait for the pulse of the echo pin to come back. For that, I'm just gonna create a variable. It's gonna be a double, since the value is gonna be in microseconds. This value can get to be really big, and you can use doubles in Arduino, even though it's a pretty low power processor. Sorry, microcontroller. You can still use doubles and floats and everything that you're used to in Java. So no worries there. Double, and I'm gonna call this duration. This duration is gonna be this duration is gonna be this exact same value right here. And for this, I'm gonna use the pulse in function that Arduino has. Pulse in. And what we're gonna do with this is the echo pin. I want this function to give me the time that the echo pin was high, pretty much. Once we have that, we can use the equation that we derived before. And yeah, I'm gonna create another double called distance. And in here, we basically grab our duration over 2, and we multiply it by the constant of speed, which is 0.0343. And that's it. We calculated the distance. I wouldn't say it's easy, but definitely I think it's understandable. I mean, you're basically playing, because we don't really have a lot of libraries for this sensor since it's kind of easy to implement. It's better to just do it yourself like this. And finally, I actually want to print the distance value into my console. So I'm going to actually add the serial functionality and serial.print ln distance. I'm just going to go ahead and run the code. Hey guys, Miguel from the future here. I ended up having an oversight in our last sketch. You can see how the echo pin is connected directly to pin number 1, but in reality, the Arduino uses pin 1 and 0 for the serial TX and RX communication with our console. Since we also wanted to use serial communication in our project, and at the same time we were trying to use the pin number 1 for the echo pin to read the value, we just ended up having a conflict and our sketch basically didn't work as expected. The way to fix this is just to use the echo pin with any other digital pin that is not 0 or 1, since in this case we wanted to use serial communication. And just doing that and then changing our echo pin variable to be 3, you can see that by starting the simulation, we get our reading that matches up with the object that the sensor is reading currently. So yeah, that's it. I hope you guys liked our first workshop, and I'm excited to see you guys in the next couple workshops that we're going to create for UPE Make. So yeah guys, have a nice day.